All right, we're gonna do the first 2 pages, and then the 3rd page of Tuesdays we're gonna save until tomorrow, because it's a lot. So it'll be a great day if we can get through the first 2 pages. It's a lot of vocab. So the first part says classify each angle as acute, obtuse, right, or straight. What is an acute angle? Less than 90 degrees. Okay. What's an obtuse angle? It's what? Above 90 degrees and technically less than 180. Okay. Right is how much? Equal to 90 degrees. And then straight is how much? Equal to 180 degrees. Cool. So we're going to practice our vocab, and we're going to be practicing naming angles today. So someone name an angle that is acute in our picture. Okay, 30 degrees is the measurement. I want the name of the angle. COB, perfect. So angle COB is acute. That's because it is 30 degrees. Okay, someone give me an angle, the name of the angle, that is also acute. BOA, awesome. So BOA, what's the measurement of angle BOA? 60 degrees. So this one is also acute. All right. Hey, what does that make angle COA? It does make it right. It makes it 90 degrees. So angle COA is right. Cool. Do what? Do what? COD is what? Okay, why? So, okay, so the statement was if COA is right, then COD has to be right, but why? Do what? Sort of. Somebody set it up here. Good. So DOA, notice, angle DOA is straight, which means it makes 180 degrees. That's why we can say COD is 90, because we know DOA is 180 degrees. So angle COD is right. Notice, what's the middle of every angle name we put up here? O, because that's the center of all of your angles. That's the elbow of all of your angles. Your elbow has to go in the middle of your name. Questions? All right, so using the angle measures in our picture, tell me 2 angle measurements that are complementary. Give me the angle measurements, not the names. 30 and 60. Good. All right. Which 2 angle measurements are supplementary? I think I heard 90 and 90. We just want the angle measurements, so we want the degrees. We don't need to use the names here. The next question is asking, what do we call 2 adjacent angles that form a straight line? Adjacent we haven't talked about yet. What does adjacent mean? Okay, I like that last statement, that last part. So let's use an example. Let's see. Isaac, raise your hand. Awesome, there's Isaac. Cooper, raise your hand. There's Cooper. Isaac and Cooper are adjacent. What's adjacent? Beside each other. So adjacent, we can say beside each other, we can say side by side. If they are side by side, that means that they share a side. So 2 adjacent angles share an arm, okay? They share a ray. If 2 adjacent angles form a straight line, we call that a linear pair. What's linear mean? Line, pair, 2. Does pair mean 3? No, pair means 2. So if you have 2 angles that are side by side, they share a side, and they form a straight line, it's called a linear pair. That's a vocab word you need to know. Give an example of this from the diagram above. So give me 2 angle names that are next to each other, and they make a straight line. angle DOC, and angle COA. So DOC was the right angle that we talked about on the left side, and COA was made up of the 30-degree angle and the 60-degree angle. Both of those go together to make a straight line. That's a linear pair. Questions on that? All right. The next problem says given, so they're giving you a couple of details, okay? It says M in front of the angle mark. This means the measure of angle WYZ. That's what that says. When you're talking about the measurement of an angle, you're talking about how big that angle is in degrees. And so this says the measure of angle WYZ. If we go from W to Y to Z, we're going W to Y to Z. We can see that that's going to be the right side angle, okay? That is 2A minus 5 degrees. I'm going to tuck that in there so that I can see it in the picture. The measurement of angle XYW, if we go from X to Y to W, that's our right side angle, is 3A plus 10. So we've got 3A plus 10 degrees. They want us to find A. What do you know? Yeah. What do you know about these two angles in our picture? Yeah, they're supplementary. They both add up to 180. They're also known as what? It's a linear pair, two angles right next to each other. They share the arm of WY. They are a linear pair. And so give me the equation I could write from the picture. So 3A plus 10 plus 2A minus 5 is equal to 180. I told you last week geometry is all about putting your picture together to make an algebra equation, and then it's just algebra from there. This is a classic example of that. You need to know your vocabulary, you need to know your angle properties, that these add to 180, and then from here it's just algebra. How do I solve that equation for A? Combined like terms, what are they? 3A and 2A. If they're on the same side, you do what it says, you don't do the opposite. So this is going to be 5A. What else? 10 and negative 5 make what? Positive 5 equals 180. Now what? So I heard minus 5. Why don't we divide by 5? Do what? Okay, why do we do it after? Do what? Sort of. Actually, when you're solving, remember PEMDAS, order of operations? Yes. When you have nothing but numbers, you do PEMDAS in the order that PEMDAS is, starting with P and going down. When you're solving, you actually undo PEMDAS from your variable. So you have to undo addition and subtraction to your variable first. The only thing being added or subtracted to A right now is that 5. That's why we subtract 5, so that we can undo that. And so that gives us 5A is equal to what? 175. Now that we've undone our addition and subtraction to A, now we can undo our multiplication and division to A. 5 is multiplying with A, so we're going to divide by 5. If you struggle with multiplying or dividing kind of big numbers, then I would suggest you become a chunker. And that means chunk whatever you're dividing into numbers that you can divide. So I know that I can divide 100 by 5, and 75 is still a little tough for me, so I know that I can divide 50 by 5. What do I need to add to those two to get 175? 25. This is called chunking. If I divide each of these numbers by 5, and then add them together, I'll have my answer. So what's 100 divided by 5? 20. What's 50 divided by 5? 10. What's 25 divided by 5? What? You can if you know how to do it. A lot of people don't know how. What's 20 plus 10 plus 5? 35. That's our answer for A. So the comment was, can't you just do long division? A lot of people don't know how to do long division. If you don't know how to do long division, another option could be chunking. Chunking can also sometimes be faster than long division, but that's completely up to you. Questions on that? Classify each angle as acute, obtuse, right, or straight. What do I need to know about my angles in order to classify them? Can I go by the picture? Can I just be like, man, that looks like a right angle? No. Can I hold the corner of my paper up to it and be like, that kind of matches. That's kind of like a corner of my paper. That's a right angle. No. First lesson in geometry is never trust the picture. Ever. Ever. Because sometimes, most of the time, it's not going to be to scale. And the second you trust that picture and you just kind of like eyeball it, that's the second you're going to get it wrong. So don't trust the picture. What do I have to do with both of these angles to figure out what kind they are? Yeah, I'm going to have to plug A in and actually find what the measurement is. So let's say first equation that they gave us is measurement of angle WYZ equals, and they told me 2, and then what's 2 and A doing right there? Right here in this equation. Multiplying, so I've got multiplying by A is 35 minus 5. This is where you do PEMDAS in order, because you only have numbers. So let's multiply first. What's 2 times 35? 70 minus 5. 65 what? Degrees. That makes angle WYZ what kind? Acute. It is less than 90, so it is acute. Good. Let's do the same thing for the next one. Read that equation to me. Measurement of angle. I just don't want to scroll up. X what? XYW is equal to 3 times A, right? 35. And then is it plus 10? Plus 10? Yeah. This is another place where if you struggle with 3 times 35, you can chunk it. Are you ready? What's 3 times 30? 90. What's 3 times 5? 15. Add them together. 105. So 105 plus 10 gives me 115, which makes angle XYW what kind? Obtuse. Does that match our picture? Yeah, it looks appropriate. But again, the second the picture is off, you're going to trust it and you're going to get it wrong. So don't trust the picture. Ready to move on? Scream if you're not. Okay. I'm going to pause. What's the complement of the supplement of a 110-degree angle? Let's start with the second part. Let's start with the supplement of a 110-degree angle. How do we find that? Close. 180 minus 110. What do we get there? 70 degrees. Okay, what's the complement of that angle? Why? 90 minus 70 is 20, so this is 20 degrees. Awesome. So you kind of got to go a little backwards. If the complement of an angle is 20, find its supplement. So let's start with the original angle. If its complement is 20, what is that angle? Its complement, that means it adds to 90. What's that angle? 70. And if our angle is 70, what's that angle's supplement? It's what? 110. You do 180 minus 70, and you get 110. Oh, why did I put 27? 20. There we go. Questions on those two? If you don't have questions, you can flip it. This is on the back side. So explain the word dilate in your own words. Have you ever had your eyes dilated? Anybody? I have, and it's horrible. I pay the upcharge. I think the replacement for dilating your eyes is like the puffer machine that like puffs in your eyeball. I would much rather have a machine puff air into my eyeball than have them dilated. Do what? Yeah. It depends on your doctor's office, but like my office has like an alternative to that. I think it's the puffer machine. I think. It might be the one where I have to like look into it, but I think it's the puffer machine. It's crazy. The only nice thing, the only cool thing about dilating eyes is like the eye drops they give you is like the color of a highlighter. I think that's pretty cool. But other than that, it is not fun. What do they do when they dilate your eyes? They make your pupils big so that light gets let in, more light gets let in. Okay. So they make them bigger. All right. What's a really nice word for making something bigger? Ooh, enlarging is good. Okay, so dilating, we could say enlarging or shrinking. Okay, so when we dilate, we're going to be multiplying by what's called a scale factor. Usually the letter for scale factor is K. I don't know why, it just is. Okay, if we're multiplying by something and we're trying to enlarge it, what are we going to multiply by? Do what? We're multiplying by 2 today. Yes, something bigger than 1. So enlarging, your scale factor is going to be greater than 1. What if we're trying to shrink something? It's going to be what? Yes. What is it not going to be? What's something that you think could happen? Okay, so if it's a decimal, what kind of decimal are we talking about? Because I can have like 1.5, right? Oh, below 1. Okay, so what's a number below 1 that we don't want to use to dilate? 0. 0's not going to change anything, right? What's another number less than 1 that we don't want to use to dilate? A negative. What does multiplying something by a negative do on a graph? It's a transformation we've already done. Nope. Reflects it. So we don't want to do a negative. We don't want to do 0 because doing a negative will reflect it and doing 0 won't do anything. So for shrinking, you're going to have a scale factor that is between 0 and 1. So it's going to be greater than 0 and less than 1. All that means is that it's probably going to be a fraction or a decimal that's smaller than 1. That's not negative, okay? So we're going to dilate segment AB by a factor of 2 from the origin, and I give you the rule. What's the deal about the rule? You have to memorize it, and it only works from the origin. Notice we're dilating 2 different times today, and the second time we're going from point B. Your rule does not work if you're doing it from a specific point, okay? So we're going to dilate by a factor of 2. To dilate something, let's figure out where the origin is. I'm going to put a dot at my origin. All right, there we go. To dilate something, we're going to find our path from the origin to A, and we're going to double it. So how do you get from the origin to point A? Okay, I heard right 2, up 4. Double it. Right 4, up 8 from the origin. So we're going to go from the origin, right 4, up 8, and that's going to be A prime. So you find your path from wherever you're dilating from, here it's the origin, to the point, and then you're going to double that because it's a scale factor of 2. How do I get from the origin to point B? Left 2, double it. Left 4 from where? The origin. So left 4 from the origin, and that's going to be B prime. Draw your new line segment. What do you notice about A prime, B prime? It's what? Parallel. Every time you dilate something, your new line should be parallel. So even if you're dilating like a triangle, the sides of your triangle should be parallel to the original sides, okay? What else do you notice about the line segment? By how much? 2, yep, so it's double the length. All right, now we're going to dilate segment AB by a factor of 2 from point B. So we're going to be on point B. How do you get from point B to point A? Over which way? Right 4 and then what? Up 4, double it. Right, how many? 8 up. 8 from where? from point B. So go from point B, right 8, up 8, and that's going to be A double prime. Okay, how do you get from point B to point B? Did I? Oh, I did. I messed up this one. It's supposed to be right here. Sorry. Oh, that's terrible. There we go. So from B to A, because we're dilating from point B, from B to A, I'm going right 4, up 4. Yes? Doubling that, I'd start from B, and I'd go right 8, up 8. How do you get from point B to point B? 0. You don't, right? You're already there. So is there a way to double your path from B to B? No. So B is B double prime. And then draw your new line segment. What do you notice about your line segment? It goes through the original segment and it's double the length. That should happen when you're dilating something by 2. Which segments are congruent? What does congruent mean? Same what? Shape and size. So same shape, same size. All of these shapes are what?
Straight lines.
Line segments, yes. And then same size. Which ones are same size? So A prime, B prime, the line segment. And then let's put the congruent mark, squiggle with an equal sign. And then A double prime, B double prime, the segment. Why? How do you know? Yes, that doesn't show congruence. They're both what? How did we get both of them? Yeah, we dilated AB by a factor of 2, so they're both double in size from AB, the segment. If we took AB and we doubled it in size 2 times, then the 2 results are going to be congruent because they're the same shape, same size. Which lines are parallel? There's a way you can get around the notation here if you're clever. Is AB parallel to anything? The original? Do it. A prime, B prime. Is A prime, B prime parallel to anything else? A double prime, B double prime. So they all are. All of them. And the reason for that, dilating preserves slope. It also preserves something else that has to do with slope. Are A prime and B prime collinear? Collinear means they're on the same line, so yes. Are A double prime and B double prime collinear? Yes. Is dilation a rigid motion? What does a rigid motion do? Preserves what? Size and shape. We already talked about all of these are line segments, so our shape is preserved. Is our size preserved? No, so this is a no. And that's because dilating changes shape, or changes size, excuse me, changes size.